Okay, so welcome along, ladies and gentlemen, to your weekly SETI seminar series. And tonight we're very lucky to be joined by a very special panel, Amaresh Kollipara and Mark Bunger. Amaresh is a founder and managing partner of Earth to Orbit, which is an aerospace consulting firm and a global provider of launch services. Earth to Orbit is working with the Indian Space Research Organisation to provide commercial launch services to a wide variety of satellite clients. And in addition to his role at Earth to Orbit, Amaresh serves as a management consultant and financial advisor to a generation of entrepreneurs by helping them develop viable businesses and prepare for the world of venture finance. Amaresh currently serves as the principal of the Space Angels Network, which is a professionally managed national network of seed and early stage investors focused on aerospace-related startups. Prior to his aerospace-related endeavors, Amaresh enjoyed a successful career with the strategy group of Accenture, where he managed key internet strategy offerings and developed strategy recommendations for Global 500 clients such as Cisco, HP, and Siemens. Amaresh's diverse background also includes roles as a biotechnology researcher, planetarium presenter, and physics teacher. Amaresh holds an MBA degree from the Graduate School of Business at Columbia University, and he also earned a BA in molecular and cell biology with an emphasis in neurobiology from UC Berkeley. So Amaresh, if you want to come to the podium and okay, please join me in welcoming Amaresh tonight.
Thank you. Thanks. Thank you, Adrian, for the great introduction. Can everyone hear me okay? I assume you can. Great. So I wanted to go through a couple of concepts or themes tonight that would be applicable, hopefully, for the audience. And the main gist of my comments are going to be centered around Network is, as Adrian said, is a group of angel investors. We're actually now global in nature, and we consider ourselves, we are the only angel investment group focused on space and aerospace-related deals. And we actually do have several entities that are working with us to fund science research as well. And so kind of based on these experiences, I kind of came up with a few themes that we'll walk through tonight. And of course, in the Q&A session, I welcome any comments or questions, that we can go from there as well. So I'm going to kind of dive in, but I'm also going to walk around a bit, and hopefully we can make this more of an engaging type of conversation. So I may drive our webcam guy in the back a little crazy by walking around, so I apologize in advance. My contact details are here. I'll flip back to the slide when we're done, but my email you can jot down at the end of the presentation. So here are the several themes that I wanted to Offworld applications. But each of these applications has revenue potential or monetary potential behind it. And that is the true driver for seeking investment. So that's theme number one. A couple of sub-bullets underneath that. Science research is definitely not only an academic construct. It is a commercial construct. And oftentimes, the way to enable that is purely communication. One of the obstacles that I've seen before in getting investment, whether for a commercial concern or science research, is the ability to communicate the business viability of that thing. So it comes down to communication. We're going to talk about that for a bit. And science research has tremendous potential in making existing business ideas or concepts faster, better, and cheaper. So it's basically a disruptive way of doing business. We're going to talk about that as well. So at this point, I'm going to go through a very quick analogy. And I think this analogy should fit with our theme for tonight. Some of you in the audience have seen this before. So when you think about space or aerospace, this is the analogy I'm drawing, you think about certain things in your mind, certain images or certain concepts. When you think about science research, certain things or concepts jump into your mind as well. So what I'm challenging those in the room to do tonight is to change your definition of what science research is. That's my challenge to you. Slightly change your definition of what science research is. And we're going to walk through what I think that definition should be changed to be. So as an analogy, when people think about, well, today we're going to talk about a biotech example, and also I'm going to talk about why investment is available and out there to get now. When people think about space or aerospace, is the analogy I'm drawing today, they think about images like this, or images like this, images like this. These are all standard traditional images when the concept of space or aerospace comes to mind, whether it's in this room or outside of this room. Images like this, traditional notions of space and aerospace. And of course, this image as well. The International Space Station, once again, traditional definition or notion of what space or aerospace might be defined as. But let's expand the definition. I would argue that this image you see before you is just as space or aerospace related as the previous images. GPS applications, satellite TV applications, satellite radio applications, geographic information system, or the underlying data that can be gathered from satellite imagery and related applications. Eventually, one day, mining. Protein crystal or DNA relevant applications that are done in space. Pharmaceutical applications that can be driven by things that are done in space. So here's the analogy. We went from a traditional definition of what space or aerospace might be and expanded it to something that I call more application relevant. So the theme essentially that I'm trying to bring to the forefront is when you think of science research, regardless of what discipline it's in, biotechnology, materials, physics, astrophysics, there is always an underlying application behind it that expands the definition of that traditional area or entity. So let's talk quickly about the Space Angels Network. We'll kind of jump back into our themes in a bit. So the Space Angels Network, like I said before, we're a group of investors. We're approximately about 30 investors right now, spread throughout the world, but mostly concentrated here in the US. And we're focused on early stage aerospace and space-related deals. These are early stage companies that are looking for money. They come to us, we work with them, and we invest in some. And the investors that make up that approximately 30 members have a very diverse background. They come from investing in high-tech companies, some in biotech companies, some in aviation companies. So with that diverse background, they bring kind of a diverse way of vetting companies and deciding whether to invest or not. So we think of ourselves as a catalyst for moving along or creating a new fledgling industry, so-called new space industry, which is growing as we speak. One of the ways that the Space Angels Network adds value is that traditionally, angel investors like to invest in their local geographic region. And unfortunately, space and aerospace-related deals are very rare. They're far and few between. So because of that, what we've done is tried to create a virtual network. Essentially, there's space deals throughout the world. There are also angel investors throughout the world. Rather than having them invest in their local geographic region, we've developed a way to kind of make this whole thing virtual. So we conduct virtual meetings, we conduct virtual vetting seminars between our members, and the idea is to make angel investment no longer traditionally local, but truly global. Our founding members are listed here. For those who are familiar with angel investors, they're some of the most prominent folks in the industry. And we have a large team of organizers. I'm one of them. And we help facilitate the process of getting new companies in front of the investors such that they can invest in companies they like. A few logos up there on the experiences that our team brings to bear. One interesting thing is that since investing in space and aerospace is relatively a new idea or construct for angel investment, we help provide kind of a collaborative atmosphere for investors that are interested in this area. Rather than them going off on their own and essentially investing in companies that they don't know too much about, or forging a new investment industry within the space area, we tend to provide a little bit of collaboration, so our investors are not the only game in town. They don't act individually, they act more collectively. And once again, for the entrepreneurs or companies that are looking for investment, we help them meet investors and we kind of coach them along the way as well, such that their pitches are more effective. So here's some of the companies that the Space Angels Network members have funded or founded. Some of you may be familiar with these companies. And some of these companies actually, in addition to their revenue making or the revenue generating goal, a lot of them are doing science research as well. Planetary Resources is one of them. So we'll talk a little bit more about some of these companies later on in this talk. We also work with several folks that help us run this Space Angels Network. So let's jump back a bit to the previous theme that I talked about, is the definition of what science research is and how we expand that. So the main, what I'd like to propose is one of the main obstacles towards getting investment for science research is communication. It's not necessarily the research per se, but it's the ability to show the investor that the research that one is doing, or a team of folks is doing, has commercial potential. Whether or not right away, it does in at least 3 to 5 years' time, and the steps that are required to make it commercially viable. That's generally the way. That's generally the main obstacle that I have seen in the Space Angels Network's experience in getting investment for science and research related endeavors. So, very simplistically, the 8 things you see on the slide up here are kind of the must-haves when an investor is evaluating investment in a commercial entity or even in a science research entity. So they're very straightforward, no need to kind of go through them. But I'd like to kind of focus your attention to 5 and 6. The how you make money bullet. This may not apply directly to science research per se, but this is where the expansion of the definition comes into play. So science research, regardless of the discipline that it's in, like I said before, I believe, has, beyond the academic definition of it, has tremendous commercial potential, real-world application potential. And I think the ability to translate that, regardless of necessarily the time frames that it takes to translate that, that is the critical key. So I think that's kind of the fundamental facet that most investors, or donors for that matter, would gravitate towards when evaluating whether to put money into a certain project or not. We'll come back to this too in a very short bit. Investment or money going towards science research is not a new and novel thing, of course. So here's a list of the top 10 university technology transfer programs. If you add all those numbers up, it's a pretty big number. These are annual numbers, and this is actually taken from 2009, so these numbers have increased. So a lot of these funds come out of biotech-related research. A lot of them come out of semiconductor-related research, and some of them actually come out of material science-related research. And once again, all of them are not, all the projects that kind of drive this money a lot of them are not commercially viable per se yet. A lot of them have commercial potential in the near future. But the key is that all of them have essentially articulated the commercial value such that someone on the outside of the university put money in. So most of this money is coming from royalties or licensing agreements. Some of it's coming from investments as well. So one thing that I think is very important is actually that we're here at the SETI Institute, which I think is sitting on a gold mine of technology commercialization / science research potential. I would easily argue that SETI Institute could belong on this list as well. So let's go into a quick example. I'm going to talk about a biotech example. Thus the Arctic's depiction of a double helix here. Not sure how realistic that looks, but we'll go for it for now. Back in the mid-70s, some would argue 1976 was actually the true beginning of the modern-day biotechnology industry. So in '76, Genentech was formed, and it was actually formed by an investor, a guy named Swanson. So he put money into this idea. He actually chased down the science research project. He went out and chased down the scientists that were working on this, and without them asking, he put money in. He put money in because he essentially saw answers to all these questions. And once he put money in, he essentially helped Genentech become a viable concern, all based upon the science research topic of recombinant DNA technology, which is the basis for pretty much any biotechnology concern today. It essentially, like I said before, the main driver was this. The main driver was essentially the points on this slide. Without the points on that slide, I don't think that investment would have been made. So there are quite a few other examples like this. This is not the only one. But I like to point to this one usually because it started what I think, it truly started the actual industry of biotechnology and how we define it today. There's other examples as well, like in material science. There's quite a few examples in internet-related research as well. But this one I think is more attuned to the specific definition of what science research can be. I'm going to end with one point, and then we'll move on from there. Notice on this slide right here, you don't see how far along the science research is, or how perfected the research is, or to what degree of certainty the research is positive or negative, or to whatever measure that one would measure the quality of science research. That metric is not on this slide. And the reason I point that out is there's pretty much in every type of industry that the Space Angels Network has looked at, and also that I've worked in the past, very rarely does the absolute quality of either science research or the technology come into play to the extent that these come into play. So some examples in the history of applications or business out there are things like, why did Google become much larger, more successful than Yahoo or Alta Vista or Lycos or any other list of applications that were similar? Now, I mean, this is an obsolete example, but why did the VHS format beat out Betamax? Why is Facebook around where MySpace is dying? Some would argue that the technologies or the quality of the products or applications that are no longer around may have been actually better than the ones that survived them. So that's a kind of a weird theme that I'm leaving you with, but the answer to these questions does not necessarily depend on whether the science and research that one is doing is of whatever metric you use, 95% quality versus 100% quality. The variation in the quality of the research or the type of metric you can apply to it is not necessarily a true determinant on whether investment comes in or not for that project. It's the ability to position it relative to these bullets, I think, is actually more critical. I'm not saying by any means that junk science is investable, not at all. I am saying that all else being equal, these are actually very important. That's the main point. So, with that, thank you for your time. I will turn it over to Adrian. Thank you.
Thanks, Amaresh. I like the sound of the SETI Institute sitting up there next to Stanford, the $60 million mark. I think that'd be great. Okay, so Mark Bunger directs the Lux Research Analyst team from the firm's San Francisco office. He has 15 years in business strategy experience, both as a management consultant and a technology analyst. And in this time, he's managed more than 40 Fortune 500 corporations, led hundreds of engagements and authored over 60 reports and other applications. The first 6 years of Mark's career were spent at Accenture in the US and Europe, where he is a consultant on a variety of industries and technologies. And Mark's education includes international marketing from Sweden Institute. I'm not going to attempt to pronounce that. And market research at the University of Texas. And in addition, Mark's also studied biochemistry at the University of California at Berkeley, and currently assists part-time in the lab at the UCSF Department of Neurology. So I'm not sure that we're going to hear about that today, but if you'll please join me in welcoming Mark to the podium.
Okay. Yeah. Well, first of all, I do need to update that a little bit. It's been a long time since I've worked at UCSF, so it's probably about 5 years out of it. About 20 years experience now, and it was about 5 years ago as a lab assistant rat at UCSF, neurology and bioengineering. So that said, let me pop up presentation. Well, first of all, I do need to update that a little bit. It's been a long time since I've worked at UCSF, so it's probably about 5 years out of it. About 20 years experience now, and it was about 5 years ago as a lab assistant rat at UCSF. So I think one of the things that brings a lot of us into space as an industry is not that it's the best, most lucrative industry we could conceivably be in. Is anybody in space for the money? Good, that's because you're smart people. It's not, this is not why people get into space. We do things like, set course to intercept, words like that, that we often hear from science fiction, just arouse passions and interest and excitement that almost no other industry or no other technology can do. So there's a lot that makes this a very complicated field to get into as an entrepreneur, as a scientist, and as an investor. And what I hope to do, building on Amaresh's great talk, is talk about how we see those two things coming together. So private money and really, really good science, how can we make those things into how can we mix those up? Really quickly about Lux, I don't expect you to read this. In fact, I don't expect you to read anything on my slides tonight. I'm happy to give them to you, and I put in more than I intended to present, just in case you wanted to read later. So definitely you can read them at your leisure, and we can follow up if there's anything that we don't get covered tonight. But really briefly about Lux Research. What we do is we cover these technologies, things like solar, food and nutrition, water, agricultural innovation, advanced materials, and so on. Each of those blocks is a team at our company. We have about 90 people in total. And what we do is help corporations that work in those industries to find technologies like the ones that you might be working on. So just by show of hands, how many of you are developing a technology that you're looking to get some investment for or something like that? Okay. How many of you came here with a bag of money and you're looking to spend it on some technology? Okay. Well, all right. So since there aren't that many people here, I'm not saying that I represent that group, but that's where our clients are. They are large companies that generally spend hundreds of millions, if not billions of dollars on R&D. They tend to be some of the biggest and most advanced companies in the world, and they do want technologies that are often developed for something like space, but they're going to put it into a medical device, or they're going to use it for oil and gas exploration or something completely different. So that's basically what this slide says. As I said, we have about 90 people, and this is what we do, is we get to scout for technologies and then bring them back to our clients. So when we look at new space, this is just let's say a hand-wavy diagram, since we're a lot of probably hard scientists in here. This is generally speaking the types of categories we see in the new space industry, again, that Amaresh referred to. So spaceflight systems tend to be things like launch vehicles, sensoring and monitoring platforms and services, human transport and habitats, and then metals and mining, which is kind of new and unexpected. But again, as Amaresh pointed out, we need to find a terrestrial application for most of these things. There is certainly space business, but 99.99% of the money that's going to be made on these technologies is going to be made, between here and 5 or 10 miles up in the sky. So terrestrial applications of each of those things are the way we help our clients translate those technologies into something that they could use today or in the next 5 or 10 years. Now, there are exceptions. There are things that you can only do in space, and space is an opportunity in and of itself, and we look at that as well. But when we take, again, something that's kind of general and qualitative like this, we also need to be very specific about what it means. So these are some of the companies. If you said, well, I'm interested in using satellite imagery to monitor my fleet of trucks or my oil field or something like that, we'd say, well, NanoSatisfy or Skybox Imaging or Planet Labs are some of the companies that are shooting up satellites to do that type of work today. How much money do they make? How many satellites do they have? What are the performance specs on those satellites? How much do they cost? Those are the types of analyses that we do, and again, really translate that general picture into something that they can take action on. Should I invest in this company? Should I buy its products? Should I wait for 5 years because they're going to get better, and then it'd be a better time for me to pull the trigger? So I'm going to use this particular category right here on sensing and monitoring platforms and services. So things like CubeSats are a really popular topic these days, and they really fall into this category. And I'll refer back to this mostly throughout my presentation. But as I said, we do look at the other areas as well, and we basically try and say, who's in that space, how well are they performing, who are their investors, are your competitors busy there, and what should you do about it? So new space is a really exciting area, and the thing I wanted to do, since I assumed that most of you were going to be not familiar with the financing part of it, is talk a little bit about financing. So why did NanoSatisfy get any money, or Planet Labs? Who's making the decision to invest in these things? And generally, living here in Silicon Valley, we think, well, it was Kleiner Perkins, or it was Khosla, or it was a venture capitalist. That's kind of like the 49ers, or that's like our sort of favorite team here, right? We're all, oh yeah, venture capital, we do that better than anybody in the world, and that's totally true. But the long-term trend in venture capital is actually declining. So what this says in so many words is if you look year by year, venture capital is on a long-term slow ramp down. And there's some reasons for that. I mean, I can guarantee it has nothing to do with the recession or the lack of a recession or the Jobs Act or Obamacare or anything. It has to do with the fact that venture capital is very, very well suited for two things: software and medical biotech. Almost everything else is a stretch. Everything else is a poor fit. So if you look at all the clean tech investments that Silicon Valley venture capitalists made recently, bless their hearts, thank you very much for putting so much money into what, something that ideally is going to benefit all of us. They totally lost their shirts on that. They did not do well at all. It just doesn't fit their model. So there's some fundamental economic reasons for that. It has to do with fixed costs and variable costs and things that we can get into maybe as a sidebar conversation. The point is, if you're looking to fund your space venture, this shouldn't be, it shouldn't be your first stop. You might check them out, but there are a lot of other sources that you can go to. So one of them is corporate VC. So like I said, I represent corporations and their venture arms, or their R&D arms, their business development arms. I'm not representing them in the sense that I would get any portion of what they spend on your technologies. My job is to be really objective about both sides. But I can say that, generally speaking, corporate investment for you as an entrepreneur and for the corporations is a much better deal. So most of the companies that we're familiar with have, here in the Valley, have VC arms these days. So Google Ventures, Intel Capital, T Ventures, T-Mobile, Bosch has a venture capital group. So all around the world, large corporations that are involved in science and engineering tend to have venture arms these days. So they're generally investing larger sums of money than Silicon Valley investors can afford, and they're also smarter about it. If Bosch puts money into your startup, it's because they want that technology at some point to go into one of their products. So from an engineering perspective, they're more astute, and they're also not out there to basically get 10x return on their investment. They'll get their 10x return on their product. Their job is to make you as an entrepreneur successful. So there's that angle of it. There's also, you can just look at, this is from Harvard Business Review, look at the numbers. Startups backed by independent VC firms, by corporate VC firms, risk-adjusted monthly excess of market return, annual revenue growth, increase in return on assets, and the corporate guys greatly outperform them on just about every measure there, or on every measure. So traditional VCs are not always the best match. Corporate VCs can be one good alternative. Another one is something called conscious capital, and this is it's not really philanthropy, because these people also want to see a return. So it's a way of doing philanthropy that has a real business focus. So the Bill and Melinda Gates Foundation, the Skoll Foundation, Breakout Labs, which is Peter Thiel's, one of the PayPal founders' foundation, Bezos Expeditions. These are generally very, very wealthy individuals or families that have started a foundation to invest in things that have a really, really long-term payoff and generally have a payoff for society, not, say, in financial terms. A lot of space type research, long-term things get funded this way. Another one is competitions. So you've probably all heard of the X Prize. Anybody heard of the X Prize? Yes? Okay. So the thing about competitions, I like to put it this way. If you would, say, go down to the park and just see some people running around in a circle, it'd be pretty boring, wouldn't it? Right? But if it's a race, there's a contest, and like at the end, somebody's going to get a prize, then all of a sudden this becomes incredibly exciting. And you're rooting for people, and there's drama, and there's a lot more excitement and liveliness, and they run faster because there's a competition. So competitions generally don't provide a whole lot of funding, but they do provide a lot of know-how, and they really bring out the best in the companies that are involved in it. So there's lots and lots of these. There's a group called the Institute for Competition Sciences that's based in San Francisco, and they actually track those competitions. And they get involved in some of them, like the Night Rover Challenge. Has anybody heard of the NASA Centennial Challenge? Night Rover? So the Night Rover Challenge is actually related to one of the companies, or one of the presenters that we heard earlier today at Stanford. It's basically, if you're going to the moon or Mercury or some other planetary bodies, their rotation is such that you're going to spend 2 weeks or maybe months or a long time in darkness. So if you went up there thinking your solar panels were going to keep your rover running for a long time, you won't have a successful mission. So they're looking at things like energy storage technology, so better batteries basically, better solar panels, low power electronics, and innovations that all can help those rovers have a more successful mission. Now, obviously all those things have terrestrial applications as well, and that's really why these competitions get funded by people that don't have a stake just in, say, exploring the surface of Mercury. And then there's also crowdfunding. So I'm sure everybody has seen the number of successful nanosat companies get funded through Kickstarter. Now, just like with competitions, this generally is not all the funding they ever get, but it's a great way for them to spread their exposure. A lot more people find out about what they're doing, and it's pretty surprising how advanced some of the technologies are that are getting funded on Kickstarter. So one I'm pretty interested right now is looking at using water propulsion for CubeSat. It's a nice little technology. Maybe it isn't going to be something that NASA needs to invest in, but what's exciting is that if you're going to put up some kind of a chemical propellant and stick that on a nanosat, you're not going up on anybody else's rocket. They're not going to take you on board. But if you're just going up with water as a propellant, maybe you can ride a secondary payload on a lot of missions that you otherwise wouldn't get a ride on. So anyway, there's a lot going there. This is another area that's really growing. So, and the other thing is, by the way, it's not dilutive. If somebody makes an investment in your company, you're giving up part of your company. If they give you money and you give them a sticker or a product, or you tweet from your satellite, you don't have to give. You still own your company, which is nice. So anyway, taking all those trends and sort of triangulating here, the blue line basically is venture capital. These bars are all the things I just talked about. And as you can see, they're converging. This year, they will probably cross. So venture capital will probably be less than the total of the other 4 areas that I told you about. And those look to be really long-term trends. So again, if you're looking for money, do look outside the traditional Silicon Valley venture community for those funds. Okay, so I'm going to pause there. Well, no, I'm going to keep rolling. Excuse me. Okay, so I wanted to give you some more ideas about specifically how private money uses space-based research. One is as a supplier. So normally, companies are not looking for a complete solution. They don't expect you to have that, and frankly, they won't believe you if you say you've got it. They're looking for a problem to one thing, like, I need a better battery, or I need a better solar panel, like I said with the Night Rover Challenge. And that's what they want to get out of you. They also might be saying, hey, I make an X, and I need somebody that's going to use that. And space is a pretty big application area for that. So maybe they want to sell something into the space market, and you're kind of their, no pun intended, their vehicle for getting into that. There's also publicity. So a lot of companies, Virgin, 7-Up, Axe, the deodorant company, a few others, they're getting into space. Red Bull, for example, they're not going to sell a lot of cans of Red Bull in space, but they sponsor Felix Baumgartner because it's just amazing. Like I said, none of us are here because of the money. It's an exciting space to be, no pun intended. So having that association is something that a lot of other companies that don't necessarily have a technology play want to be associated with. And then there's also just test beds. So I want to give my engineers a good challenge. I want to explore what might be in this area and bring that in-house. So one of the ways that we look at how a technology is evolved is very incrementally. And you can look across the board, all kinds of industries. You see incremental improvements from, like one of my favorite examples is the Mattel electronic football game. How many of you had this or played this when you were kids? Right? It was awesome. It was a completely immersive experience, better than Xbox. You could play that for hours. And there's like 12 or 18 pixels on that thing. It's red or black, and there's 3x4, and you were absolutely, dodging tacklers, and you were in that. Okay, nothing like the Retina display that we have in an iPhone today, where literally your eye can't resolve any more pixels. Unless you're a spider or a hawk or have some other type of eye, no more improvement in pixel density is going to help you, right? So from minimum to maximum, this took from 77 to 2010. That's a certain span of incremental innovation in handheld displays. Pregnancy tests. In the 20s, if you wanted to know if someone was pregnant, you needed to take blood or urine, inject that into a rabbit, and if the rabbit died, you had, or if sometimes it wouldn't die, you had to actually open it up and see if its ovaries were swollen. If that was the case, you knew this person was pregnant. Pretty difficult, right? And gross. By 1976, we had basically this thing you can just take a stick into the bathroom and you can find out right away. So that's kind of, again, sort of the most onerous, the minimum viable molecular test for pregnancy, and sort of as easy as it ever needs to be, right? You have a span. Same thing with passenger aircraft. The first passenger aircraft was a Russian plane, 1914. The biggest passenger aircraft, saving the Airbus, the A380, was the 747 that was launched in 1970. Okay, so this is all incremental innovation. You can see it takes decades. You're getting more and more passengers from roughly 10 to a few hundred. But we talk about disruptive innovation, and that's what companies want. Okay, so disruptive innovation does not happen like gradually over decades. It happens suddenly. And the way it happens is what I mentioned earlier, there's a part. You've got a part, it might be the only one, it might be one of a dozen that I'm going to bring together. So think about your iPhone. Did Apple spend decades working on digital photography before they launched the iPhone? Or phones, or anything? No, they just brought a bunch of stuff together very suddenly, and Nokia found out the hard way that they should have been doing that all along. So the way disruptive innovation happens is you take that mature product and it becomes the part of the next generation. So if you see robotics today, Double Robotics, or this little Romo thing. These are startups that are making robots. They're some of the only robots on the market. How did a startup beat? Why didn't GE make the first household robot? So they take these mature products like an iPhone or an iPad, and they stick it on a Segway or something like that. And so boom, they have a new product. The pregnancy test. Today what you do is you multiplex. You take a bunch of, not obsolete, but very mature tests. You put them on a multiplex test. So Sony makes CDs. Nobody buys CDs anymore, but they figured out a way to make those into basically microfluidics devices. So you have a reader, you have a spinner, a little centrifuge. Okay. And then passenger aircraft. Anybody know what the Stratolauncher is? Okay, yes. So this is a Paul Allen venture. Basically took a bunch of 747 parts, stuck them together. This is not quite what it's going to look like when they're done, but the idea is take two 747s, attach them, and put a rocket beneath them, and use that as your first stage to get to space. So this is how disruptive innovation happens, and this is what companies want from your technologies. How do you fit into something like this? Here's an example. This is from XCore, which is a space startup also that Amaresh mentioned and I believe invested in. And this is their test firing one of their motors, as you see here. The interesting thing about this is they took a pump. They didn't invent a pump and all the other parts of this this motor. They took a pump that was used in automotive. So they took a piston pump that had been, had decades of engineering. They adapted it, adjusted it, tweaked it, and used that same process a number of times to come up with this, their propulsion system. But if you read this quote, this is from their chief engineer. He said basically, by using readily available technologies developed over the past 120 years, we can procure high-quality components while avoiding the overhead of maintaining a specialized industrial base. This is the only way startups really succeed, is they scavenge like crazy. Okay. So this works both ways. This is I actually could sit in their mock-up. Hopefully they'll be flying someday soon. But I was in South Africa about a week and a half ago, and I saw this. So Mandla Maseko, a local DJ from South Africa, is going to be the first black African in space. He basically won a contest with Axe, the deodorant company, and XCore is sponsoring them. So I thought that was pretty cool, pretty amazing, especially since I'm talking about remixing everything, and he's a DJ, so everything's a remix. These are robots that you'll see on the International Space Station. And actually, the guy who worked on these was at the meeting earlier today. So Vidas Sunspiral, if you guys saw him, these are his robots. So these little guys float around on the space station. They do little things. What I thought was interesting, and in fact, what I thought is the most amazing thing about these, is they're powered by smartphones. So here's a NASA engineer. He's got budget, he's got time, he's got people and resources. But he said, well, why should I develop a touchscreen interface, a wireless communications protocol, a battery, all this other stuff when I could just take a smartphone for $300. There's no way you could ever develop it that cheaply. And plus you've got a base of developers who know how to fix it. And anyway, really, really smart approach to even stuff like flying robots in the International Space Station. Now, this is getting into satellites. So there are now several phone sats on orbit. HTC and Samsung are in orbit now. They didn't plan to be. They didn't know they had a space program. But that's all due to this open standard of CubeSats. CubeSats are, if you haven't seen these, this is basically a 10 centimeter cubed standard, kind of like a standard shipping container. And if you can put whatever you can put in it, as long as it's safe and meets some other requirements, and you can pay for it, you can send to orbit. So Dan Saldana, if you don't mind me pointing out, is a high school teacher here very locally in San Jose, right? He and his students have a number of CubeSats in development, going up, and can you say a word or two about what's next? So May 1st, high school students, on orbit. So anyway, doing amazing work. So things that it used to be a government program are now high school projects. So I hope to have one myself someday. So, and in fact, I'm going to wrap up with a little plug for, this is a side project that I was talking with some people. I was in Russia a few times at the end of last year, and we were talking about Sputnik and the space race and kind of how we almost killed each other. Good thing we didn't do that. And we were talking about CubeSats and came up with this idea that wouldn't it be fun if we would recapitulate the space race, but instead of having governments go at it, we would have high school and college students compete to build CubeSats. They would first do them, in CAD systems virtually, so no cost. We're going to maybe get Autodesk or somebody to sponsor that. Then the winners of that design contest would get to build with real hardware, and then the winners of that contest would actually go to orbit. So if you're interested in doing something like that, looking to raise money, but most importantly from this group, I'm looking to get expertise and mentors and judges and the types of things like that that go into a contest. So let me know if you're interested in that. My contact information is there. And with that, Amaresh and I can take some questions.
Okay, we're just going to move this podium and then
We have stools.
We did.
We have bar stools.
yeah, please. I'm going to start off with the first question, and I guess this will be to both of you guys. Something that I think that you talked on, Mark, a little bit was the idea of giving away all of your great ideas to people, and then they're no longer yours. How do you encourage these people with the?
That?
Well, no, you didn't. But this is something that an innovative person might be worried about. Is
I see.
that how do we encourage these people to approach venture capitalists, investors, and what's their best way to protect themselves and their IP? This is for both of you as well.
That's obviously a really critical question. If you've invented something and put a lot of your life into that, you don't want to just give it away for free. I mean, sometimes you do, actually. Sometimes that's the best way to make it happen and create an ecosystem around that. There is a whole open source movement. CubeSats are another good example of that. Sometimes it is good to give away one idea that's going to catalyze an ecosystem around it. But if you've got an idea, an invention, a discovery that you really want to protect and monetize, there are certain, I'd say, standards and expectations in at least the venture community about, for example, they'll never sign an NDA, and you shouldn't expect them to, and you'll look pretty naive if you ask them to. You also can't just walk in and say, I've got this great thing, but I can't tell you anything about it. Can I have some money? So there's this, what I would say is find a friendly person, like Amaresh, for example, or myself, and just say, hey, this is, you don't have to tell us the idea, but say, this is what I'd like to present to a venture capitalist. How do you think that would be received? And we can say, you're just being too secretive about this, or that's way too much to tell. And not just us, but ask some other people that you think have, can be a good sounding board for you.
Okay. If you have questions, then put your hand up and I'll come around with the mic.
Adrian, I can quickly just add to that as you
Sorry.
get
Go,
the
sure.
mic out. So the over 100 companies thus far have applied to the Space Angels Network looking for investment, and they span a wide variety or wide scope of influence. So we have companies that are dealing with satellite applications, some with software, some that are doing power management systems for satellites, some that are focusing on materials. There's some rocket companies. I mean, you name it, it's there. So out of those 100 companies, plus companies that have signed up, what we have found is that the more information they share, the higher probability of investment. And very rarely, I've never seen a case where sharing information was detrimental to any of these companies or entities. So it's very difficult to get money if people don't know about it. But the more you talk about it, shout from the mountaintops and blog about it, write about it, tell your friends, within reason. Usually that is actually better than not talking about it at all.
Yes, what is common about software and biotech that make them the only suitable fields for venture capital?
Well, just to qualify that slightly, they're not the only, but they're far and away the best. And the reason is that once you've made that discovery and that invention, your variable cost is almost nothing. So you've got a high initial cost, but after that, to make the drug or to make the software is literally zero cost, or a few pennies. So from a venture person's perspective, once you've hit break even, it's almost all profit after that. So it's called leveraged. Whereas if you're making power lines or bulldozers or something like that, every unit is still going to cost you 95% of what you're going to sell it for. So you never really make a lot of money.
Yes. We may be seeing an increase in launch frequency if it turns out that companies, some of the new space companies, actually make for reusable or partially reusable systems that economically work in that environment. Do you see launch frequency as affecting the nature of these kinds of investments and the class of activity that these various companies that you represent would be interested in?
Do you want to take that? Should I start?
Yeah.
Okay. Absolutely. So without a doubt, I think launch frequency and a reduction in launch price is really, it is a catalyst, if there ever was one, in the new space industry. And I can, you can point to dozens of examples, but in various past industries, for example, the railroad is a great example that we can draw comparisons to. Frequency of rail cars, frequency of tracks being laid down, access to different cities, created industries that no one even thought of at the time. Same with the internet. The internet is a great example as well. So if you think about as internet exposure has increased throughout the world, the number of applications and companies has developed exponentially. And when the internet was kind of pseudo-founded back in the mid-90s, and as adoption grew, no one would have foresaw the types of companies that are available today and making money because of the internet. No one, even with a crystal ball, could have pictured Facebook with 1 billion+ users back in the mid-90s. So I think the true catalyst is access to space, and that's frequency and reduction of costs. And you fast forward 10 to 15 years, there's going to be companies out there that no one even thought of today. And it's all going to be due to the fact that frequency and the reduction in cost for getting to space.
Let me ask the really hard question. Predicting emerging markets. One of the things that everybody says, oh, if we're going to do this and we'll sell 1 million of them. So, how do you predict emerging markets? And when somebody tells you, like, one of the big things that there's a lot of companies going out there right now after space tourism, is that a flash in the pan, or is that the start of a huge emerging market?
So, I think that there is it's very seductive to think about emerging markets because, we've seen surprises in the past, so therefore anything we can think of that's surprising will happen in the future. And it's really obviously, that's not how it happens. What I really wanted to do with my two examples of incremental versus disruptive innovation is show how those things do happen and why they do seem like this vast new market that just opens up all of a sudden. They surprise us at their pace because we just haven't had that vision to pull things together that already exist. But I think it's important to know that they do already exist in some form. So if you might think of, let's take Google or Facebook or something like that. Their initial application was something people were already doing. Well, people use the phone book to look stuff up, and they look in the classified ads, and those were what Google and Craigslist and those types of companies initially started out doing, is just doing something that people already did much, much, much better. But there's a term I'm guessing at least the engineers in the room are familiar with called an experience curve, which is the rate at which that technology is improving. And when an incumbent technology, it might start out better, but if its experience curve is basically flat at that point, it's not going to be getting much cheaper or much faster, whereas a new technology is actually worse, but it's improving at such a rate that it's going to overtake and completely blow that away, you know, in a predictable near-term, you know, let's say 5-year time frame. You can fairly accurately say that this or this or this is going to be integrated or it's going to overtake that incumbent technology, and that's where I think you find those really big opportunities.
Just want to comment on that, Mark. So finding derivatives of what is available today, meaning kind of what humans already do today, and finding an extension about that is probably the best predictive analog that we have today. So humans generally, we're very bad at predicting the future. We're horrible at it, in fact. Folks that make a living on it, like VC firms, are only about 8% efficient in predicting the future on the companies they invest in, which is a pretty low number.
Speak for yourself.
Maybe 12%, I'll give you that. I mean, there's a famous, you know, most of you probably have seen this funny anecdote. I think it was done by the Financial Times or a UK-based paper. They put 8 or 9 stockbrokers against a chimpanzee in predicting a portfolio of stocks. Guess who won? The chimp won. So I think finding new disruptive technologies is essentially using an extension of what we currently do, but making it faster, better, and cheaper is probably the best predictive metric that we have. I'm just mirroring what Mark said.
Yeah, well, speaking as somebody who gives away his ideas and makes a good living at it, Mark, I'd like to ask you about this space race. It seems very exciting. Are you modeling it to some degree after what Dean Kamen accomplished with the first Robotics League?
Yeah.
Absolutely fabulous what he's done. Several hundred, I think, what is it, about 500 high schools across America today have robotics teams, and the cleverness that he put into it so that half of each team at these schools is made up of non-nerds, non-geeks, who are in it for the marketing or the publicity or the charity aspects. So you are modeling this to some degree after that.
Yeah, well, I'll say to some degree because it's still at a stage where we have to look at who will pay for what, how many teams will participate, and I think that I think starting simple is the best way to do it, but ultimately the whole point of doing it is to have exactly that type of exposure and get people who would never thought they could build a satellite to actually build a satellite or touch something that's going into space. So, you know, memories they'll have for forever. And since you have the mic, and I can backtrack a little bit on my previous statement about predicting the future. So David is a very well-known science fiction author, not to just throw sunshine your way, but definitely a David Brin, legendary science fiction author. And one thing that science fiction authors do is they inspire engineers to figure out how to do what they read about. So a classic example is like, why did the Motorola StarTAC phone, one of the most successful phones ever in history, look exactly like a tricorder? Like, flip, you know, beam me up. So the types of visions that they put out are actually another good way to predict the future. As you say, well, everybody already wants X. We just don't have it yet, so maybe I can do that. So,
well,
book.
If you're going to go and try to do a Dean Kamen with this space race, I'm so behind you. Let me know how I can help.
Awesome, great. Thank you.
Mark, you'd taken some time to distinguish between the traditional venture model and, investing in the space arena. Amaresh, I mean, you'd talked about it in familiar terms of what's the market size, what's the potential for a 5-year return. So what about things that have a longer, like let's say, for example, technology for long-term human life sustainment in space, where for the, until the Chinese get a station up, our only potential customer is the space station. So somewhat limited market, even if it's a really cool technology. What are your thoughts on that sort of thing?
Yeah, I've got, I'll give you 2 examples. in order to get investment or make kind of a commercially viable entity out of something like that, I think it requires near-term stepping stones or milestones. And here are the two examples. One is SpaceX. So SpaceX and Elon Musk have always publicly stated that the goal of the company is to help colonize Mars. That's not a 3 to 5 year time frame. It's 20, 30, hopefully within my lifetime time frame, but it's well into the future. But they're making money along the way. They're developing technologies and business processes that enable them to reach that goal. And their stepping stones that they're taking along the way, whether it's developing Falcon 9, landing NASA contracts, help getting cargo to the space station, are all independently commercially viable steps. But each one of those steps helps them eventually to get to their goal, whether it's by developing new technologies or developing new processes. The SETI Institute would fall into that category as well. It is pursuing what I think is the most important and monumental human question. And it is doing so on a large time scale, which by definition it has to. But the PIs at SETI are doing amazing science research that will help lead towards that goal. But the research they're doing now does have commercial potential along the way. So it's kind of like if your goal is composed of 1,000 steps and you reach your goal at step number 1,000, every step that you take up to that point, to within reason, can, if it does, can have some revenue or commercial potential in order to enable investment to get you there. It's hard to walk into an investor's door and say, I need $1.5 billion for a 30-year plan project. But if you break it up into pieces and say, here are the steps along the way, here's the 3 to 5 year or 3 to 8 year time horizon for steps 1 through 10, that's a little bit easier to chew.
Yeah, actually, I'd like to push that a little further. So I'm glad that he asked that question first. To the actual dollar values. From my understanding, angel investment, you'll get $50,000, $250,000. Corporate VC, you might get $10 million, maybe $100 million if it's a large corporation. But cheap NASA missions are $500 million. SpaceX has gotten $1 billion already. Even Golden Spike and Planetary Resources, which you had their logos up there, need billions and billions of dollars. And so, I guess my question to you guys is who has that money? Is this, who has that money? Or if you get to the 1,000 steps that you just described, is there the king with the golden treasure at the other end?
Yeah, well, sorry.
Go ahead. Why don't you start and I'll comment
So
as well.
you take an example like Planetary Resources. For those of you who don't know, this is a company that wants to mine asteroids, which sounds pretty ambitious. You're right. It's a big project. And when I first read about that, I was like, this is completely stupid. This is a terrible idea. We're going to fly all the way out there and get a rock and come back. It's bad. But when I started looking into it and some of the actual rationale they'd put into it. So first of all, there are a lot of asteroids that fly by that are a lot closer. You have to go to the asteroid belt and then walk back. The resources are not just mineral, they're also things like water and other things that if you look at as they did, they actually said, okay, here's a rock that flew by, 8 months ago or something. And they looked at the calculated value of the water and the mineral resources and other things on that and said, okay, if we could get that, this would be worth billions of dollars. So, okay, that starts to make sense. Again, there's a plausibility issue, it's a long way away, but at least it's not as completely crazy as the first thing that I thought. And then when I was looking into it, okay, well, who does this make sense in terms of being a corporate investment? Who would do this and why? So you've got companies like Atlas Copco and Caterpillar and basically all the companies that do mining and do mining equipment, they're already looking at autonomous vehicles for doing that because it's so dangerous. So they have trucks and equipment that goes down into very dangerous environments, drills, blows things up, senses what this rock is made of, and does a lot of the stuff that you would do on an asteroid. And taking some of that technology and bringing it back to Earth or vice versa is just, like I was saying, sometimes it's just something you want to give your engineers some, something exciting to work on. But sometimes actually the only way to do it is to put a really, really hard challenge out there and say, sorry guys, you got to do 100 times better, cheaper, faster, whatever, and give them that challenge. And so that's where I think that actually it makes pretty good sense.
So to quickly comment on it, I completely agree with what you said, Mark. I also think that to kind of further answer your question, that the actual absolute number may not be that important, whether it's $1 billion or 500 million or 100 billion. Yes, they sound daunting, but that may not be the key determinant. And second, when you reach the end of the 1,000 steps, it's not like you go down those steps and then find the $1 billion pot of gold at the end. Those steps are self-fulfilling in that they drive revenue and create commercial viability along the way. So hopefully, by the time you get to step maybe 100 or 200, the other steps are already funded. So it's essentially an exponential investment growth model where every step you take increases the probability that you increase your revenue such that later investment is not required. And essentially, it's the numbers may not actually matter a whole lot. So I'll give you one example well, maybe with a show of hands. Can anyone guess what some of the largest capital investments are in industry today? Like if you think about an industry project, whether it's developing the iPhone or coming up with a new blockbuster drug like Lipitor, how much money do companies spend on projects? What's the largest you can think of? Yes.
Oil industry.
Exactly.
When they put a rig out in the North Sea,
Yep.
it sneezes like $1 billion.
Absolutely. Exactly. Oil companies sneeze $1 billion. You're absolutely right. So one of the largest projects that I've come across is the oil and gas project in the Sakhalin Islands off the east coast of Russia. The latest figures I read were over $165 billion for one project. So the numbers are not necessarily that critical. It's the viability of what comes after you invest that money. So the ROI calculation is more critical than the actual number. So,
if I can just build a little bit on that too, in terms of the technology coming towards you.
Sure.
So, Facebook didn't say, yeah, we're going to install these electronic devices in everybody's hands all over the planet, and we're going to, you don't have to build a lot of the infrastructure that you might think you need because everyone else is working on some part of it as well. So that's what I was saying earlier about an ecosystem. Sometimes it's actually a good idea to share what you're working on so that people can start to plug into that. And I mean that in a standard sense. Like a CubeSat, it's a great, just a platform to get everybody to kind of agree on a few basic things that nobody wants to compete on.
Three more questions. So if you really having a question, one, two, three.
Yeah, so I used to work for Motorola New Enterprises, so I have mixed feelings about corporate venture capital. My question is, back in the 80s when people talked about space industry, they were mostly talking about crystallization of exotic materials. They were talking about chromatography for mass production of highly purified biopharmaceuticals. They were talking about electrophoresis, zone refining, stuff like that. I haven't heard any comments about any of those technologies in years, and I was wondering if there's a reason and if anyone's currently investigating these kind of projects.
There still is a lot of talk about protein crystallization in microgravity, and I wrote about that, and I believe the title was something like, "Is microgravity a micro-opportunity?" So it's like been the reason for a long time, and maybe it still is. Now, there might be some breakthrough there, but at least the little I know about drug development and discovery is, I think that's something that sounds like it makes a lot of sense, but we need a lot of other applications than that one. And same thing with a lot of the other things you talked about. Those, frankly, I think it's not just how we think about space that's changed since the 80s, it's how we think about business and how we think about funding innovation. Those things have gone through several cycles. And I think actually to the question earlier about like this journey of 1,000 steps, I think we have developed some means to break that up into much smaller steps. We certainly have less of an appetite for big moonshot types of projects. And so maybe some of it's by necessity or short attention span or it's some character flaw. I do think we need to get back to big picture ideas. But what we have is a lot of ways to do small things in succession.
There are a few startup companies that are focusing on that. And they've flown a few flights thus far. So I think, like Mark said, it's one of possibly hundreds, if not thousands, of applications out there. And the viability of that idea will exponentially increase once frequency of launch and access to space is improved. But it's still an idea. It kind of goes on its own roller coaster ride of importance and not importance over the years. But from my latest look, there's probably about 3 or 4 companies focusing on that now.
So I didn't raise my hand earlier because I don't have a couple $1 million to throw at somebody. But, you know, for a guy my age, I'm doing pretty well. I've probably got like on the order of like $100,000 of life savings. And I on the other side of like, oh yeah, I'd love to get investment for my idea, but also like I wish there was, I'm a big believer in the creative power of capital, and I wish that I could get together with other people that were really into space and weren't Peter Thiel. And do something with my money to sort of invest in the sector. And I'd be willing to accept a lower return. If I, you know, there's this whole socially conscious investing movement right now, which is basically you're sacrificing some return for a return in some other fashion other than monetary. And yeah, I wish I could do that. Is there any way to do that and not be Peter Thiel? Not have millions of dollars to direct?
Sure. Well, I like Kickstarter a lot. I think, no, and I'm not joking. I put it up there because it's a legitimate and important new way of funding innovation. That it's too small for VCs, and frankly, it's just not. It doesn't fit their model. And so those are things that would not get funded if it weren't for Kickstarter. So Kickstarter's just, by the way, obviously there are some. I think there are like 400 different crowdfunding platforms at this point. So it's just the most prominent one. So I think that would be a great way to do it. Since your goal though is to also see a social return on that, I'd also think about how you can invest in things that that have a more of a viral effect. And by that I mean not just education per se. Don't just write a check to the local PTA. You can do that too. But finding STEM programs, so education in science and technology programs that you think are particularly good at achieving your personal goals. That might be, again, maybe it's space, maybe it's something about life in space, maybe it's something about exploration or something else. But yeah, and it's a great way to spend your money.
Thank you both for coming here and giving your presentations. I have a question regarding the, especially to Amaresh's presentation, when you had your 8 points or your 8 main bullet points. The one that really, caught my attention is the 5-year span. A lot of technologies don't mature over 5 years, and so there are 2 questions. One is a question, one is a comment. How do you price the uncertainty associated with technology maturity? Because it may not go anywhere. How do you guys price that for your customers or your clients? How do you put a value on the uncertainty associated with the maturity of the technology? The second, which not a question but a comment, is if you keep that horizon of 5 years, then pretty much you guys going to shape where a lot of the research is going to take place, and and that could be a concern, having that limitation of 5 years, because some great technologies that were developed in the past did not bear fruit over 5 years. I mean, an example is the transistor. I mean, Silicon Valley wouldn't exist over 5 years. I mean, if someone decided just to fund something over 5 years.
Right. No, excellent question. I think for my first reaction is the 5-year bullet it's a loose construct. Generally, 3 to 8 would be kind of the numbers that most angel investors and possibly some VCs look at. It's basically to try to put some type of scope on the time horizon in order to recoup some of that investment. So it's an artificial time horizon that's kind of semi-dictated by investors. So how do you deal with that when you have a technology that's not mature yet? Or how do you view that? Kind of in twofold. One is the technology itself need not be drastically changed to fit into a time frame for investment, if that's the only thing that the project is running towards. So it's kind of like the 1,000-step idea that we talked about previously. If the technology maturation for a technology is envisioned to be 20 years, but there's a few stepping stones from between now and the 20-year time horizon that could have revenue potential, that is entered into the calculations. But I wouldn't call them calculations per se. These are kind of a loose guideline used to kind of assess the viability of a potential investment. It's not an exact science. Sometimes people put an exact science to it, where they kind of measure the future potential of a market and then size the investment based on that. But I'm a firm believer that trying to predict the true number of a market now, that's potentially 3 to 5 years in advance, is applying too many, it's applying exact science to something that's fundamentally not exact. It's essentially putting lipstick on a pig, to use that analogy. So it's basically, it's kind of a loose guideline. So it's basically, if you have two comparable technologies and all else being equal, obviously the one that has more revenue potential earlier on, based on estimates, gets the nod for investment, if ROI is your only true measure or true determinant. So that's kind of a roundabout way of answering your question, but it's, to summarize, it's a loose guideline. It's generally viewed that way by most investors, but it need not be the only guideline. So it's not a make or break issue if that 5-year horizon is not stuck to.
A very quick question and completely unrelated to the NIAC technology that I'm doing here this week. The takeaway from your talk is it's all about the applications, the value of your idea. And the ways you protect things from IP, and if you're looking at a portfolio to go to VC, the thing obviously is, okay, you have certain patents. So if you have one, say, interesting bit of goo that will do 20 things, do you make 20 patents or one patent? Which is more valuable to the VC guys? do you list all those applications in the one, or do you split it out? What's your opinion on that?
There's actually terms for this: platform technology versus an application. You should certainly patent everything that you can within reason. You know, patents aren't free, but there is a frequent debate about what's better to have. And generally how we see this play out, and we see it a lot, we cover like 1,500 companies a year. The company is all about the platform. I can do so many things with this. I can make this and I can make that, and my goo is so fancy. A lot of venture investors will encourage them to keep their options as open as possible, because the companies that are interested in an application would be like, for example, a corporation or a potential buyer, a potential exit for that startup through acquisition. And they generally have one problem. And if you can solve that problem for me, it's worth the $10 million or the $100 million. All the other 19 things keep you from solving my problem faster. So I'd prefer you didn't think about them even while you're brushing your teeth. They want one thing solved. And so that's the tension, is you'll have traditional venture investors want to keep all your options open as long as possible. And the inventor too, you think that gives you some strategic leverage, and it does. But at some point, you have to solve a problem. You've got to put money in the bank, and you have to have revenue. And that is the thing that I think kills most startups, is they either make that decision too quickly or they don't make it quickly enough. So it's timing, there's a lot of luck involved with it, but you make it too early or too late and you're literally bankrupt. So, and that's not a very reassuring thing. I'm just telling you, it is a hard question. Well, like I said, it's going to be a dozen. It might be hundreds when you first start out. And what you want, this is why you want to be really choosy about who you let invest in your company, is because their guidance is going to determine whether your kids go to like a community college or the Ivy League school of their choice, because those investors are out for themselves and they're going to guide you to the quickest, best exit for them. Okay, so that might not be the big picture thing that you have in mind. And again, we talk about like why so many startups fail. Those are exactly the types of issues that end up killing them. So, you know, as an entrepreneur, you need to have a really clear, not just vision, but like of an understanding of how you're going to execute on that to make that revenue happen. And yeah, there's a lot of tough decisions. There's no blanket answer to that, but most of the time companies are going to have to succeed on one thing and then let the other ones follow.
Couldn't agree more. So the 30 plus members of the Space Angels Network, the 30 investors, all generally have all said that 2 or 3 applications that are specific and the company has a plan of action towards those 2 to 3, and there's a customer ready to do it, ready to pay for it, is much more important than having a platform where the technology is applicable for 30 different applications and you covered all your bases. So a rifle approach is much more effective in getting investment than a kind of shotgun approach. Getting a patent or not is kind of a secondary issue, I think. Getting a patent on 20 things is fine, but what do you focus on? That's more critical.
One final question. Thank you very much, Adrian. Thank you for letting me squeak in. So I'm Jay Falker. I have the privilege of directing NIAC and the Center Innovation Fund at NASA headquarters. Guys, Amaresh, Mark, those were both fantastic presentations. I learned a lot, loved the questions, and thank you very much for hosting us here at the SETI Institute and letting NIAC participate. This is a new experiment for us, and I think something that will help some of the NIAC researchers. Quick comment, question and comment. The question is actually for me. So in the beginning, when you asked who has a bag of money, my wife wanted me to raise my hand. We don't have a bag of money, but my job really is to give money to the researchers and try and enable progress. It just isn't anything like the scale of angels and VCs. But we inside NASA are not very good at innovation. So as proud as I am of NIAC and the Center Innovation Fund, our internal pressures and the things that were mentioned here tonight that make the billion-dollar projects make it really hard to even have tiny research programs. Do either of you have advice for us, for NASA, on how to better enable things like NIAC? I know it's a curve because you're actually bringing all the other sources of money to the table, but you're the right people to ask. If I want progress, I want more of these things to make it off the PowerPoint charts and into space. Is there something I can bring back to my colleagues and my bosses at NASA that we can try and do better? Oh, and the comment real quick, if you guys did the space race, I love that idea.
Okay.
And I was thinking back to the original one against the Russians, and then how really we learned to work with them, and it saved us in the International Space. Okay.
Yeah, I want CubeSats docking, like Soyuz, little tiny little Lego people crossing the little.
Awesome, I love the Lego angle. You've even got a movie thing you can work in. But I advise you to consider a tripartite race this time, because right now we actually have another secret Cold War thing going on in space with China. My bosses, Congress, are telling us we can't work directly with China. We can't. Well, that's not actually very smart when they're the new player in the game, the other big player. So I would love to see us learn faster this time, skip the cold part, and work. And if my generation and my bosses aren't ready to do that yet, okay, but maybe the students are. So maybe you could pull them in.
Yes, that's a great idea. Well, so to your question about how can NASA, I think what you're asking is how can you see more results from the programs that you put together, like it's not just PowerPoint. And that, I think, for all its shortcomings, is the best thing about an aggressively capitalistic, I need to see my money back, structure. So the having those those measurable outcomes and having real consequences for not meeting goals and things like that, I think is probably the most important function that business-driven investment has. I do think, though, that there's a reason we have forgiving funds, which is what we have government programs for. So I don't necessarily think that you should just slavishly copy. I mean, VCs, if they said, ice cream laced with broken glass is selling really well, they'd sell it. They don't care. So the whole point of having government and other types of nonprofit organizations funding research is because we need that to balance out the really short-term appetite that business has. So that said, I do think some of the other ways you can make people compete. You see that in academic labs where you'll have two teams that are going for the same drug or two teams that are trying to solve the same problem, and every so often you just mix and match so that you have a transfer of knowledge, you have interim milestones. Structuring competitions and structuring programs so that you have just the right balance. It's different in every situation, but I do think that brings out the best in who we are as people, and that finding that that structure for the programs you run is the best advice I could give you.
Agreed across the board. I think I had very similar comments. I think what I would say is that the best advice that I could give you or government in general and how to catalyze growth like this is basically the same 8 points that I listed on the slide. The only thing I would change is the time horizon. I would change it from 5 to 20 years. Everything else would be the same. So the way that a government entity can function in enabling this type of industry or business or entities is exactly the same way that private investors would view the problem, except that government's time horizon is longer. And therefore, by definition, the government can be more risk averse. And so in the long run, the government is a catalyst. NIAC is a catalyst. And it's not a long-term enabler. It's a catalyst. It provides a spark, and then the project is self-sufficient. Unfortunately, long-term projects or businesses cannot be sustained on the back of a taxpayer for extended periods of time. So that's why a one-time injection or one-time spark that enables self-sufficient growth is kind of the model to pursue. So I would say the same exact 8 points I listed, except the time horizon a little bit longer. And the way to put that in action, I completely agree with Mark. The types of things he was talking about as far as challenges and programs, completely agree.
Amaresh and Mark, I have here a special SETI Talks mugs. I have two
Thank you
here,
very much.
one for you each.
Thank you.
They have a couple of talking robots who are talking about the Drake equation and about how they evolved from Earth. I'm sure with the help of venture capital, I'm sure that these guys have a role. I'm sure that everybody here learned plenty from these guys tonight. So please join me in thanking Mark and Amaresh for a great talk. And I know that we didn't get to all questions, so please feel free to come up and chat with Mark and Amaresh before leaving tonight. Okay, thanks very much for coming along.
Cheers. Yeah.
I've got a card
Hi.
here.
Oh, great. Okay.
Yeah. I got a patent, so I need to talk to you.